I want to talk about advanced stochastic process. Today is March 20th, Friday. So like you can define y equals to g function of x, which is the simplest form will be y equals to ax plus b. Then derived distribution, you can think about this, and you can also think about covariance. What is the difference between correlation and covariance? Correlation, think about the scale. And like if you think about x, which follows normal distribution, then fx PDF will be like this. And you can also think about g, which is joint distribution. Then what we need to do is always find the CDF and differentiate that. And I also really think about probability a lot. I thought probability is about future, but it could be more. I want to more formalize it. First, realization of stochastic process will be time series, and there's convolution, which is also an important example come out. And yeah, there's some covariance functionalities, and a correlation coefficient. You can prove it Cauchy-Schwarz inequality. And various x, you can think about. First, we need to define the e x bar y, expectation and variance, and variable x bar y, expectation and variable. It could be a bit weird, but we can think we are considering all of the value of y will get, then variance x could be e, expectation of variance x conditioning by y, and variance of expectation x conditioning by y. Sum of random number of random variables, we can think about this, and also law of large numbers and central limit theorem. In polling example, we can think about how each of theorem requires number of samples, and convergence in probability requires convergence in the distribution, but not vice versa. Convergence in distribution, the most explicit, most known case could be central limit theorem, which is Gn follows goes to normal distribution 0 to 1. This is the example of convergence in distribution. And when you think about moment generating function, there's Markarov inequality and Chbyshev inequality, and there's Markarov inequality versus Chbyshev inequality. Markarov inequality you can use proved by large number law, and moment generating function to prove CLT, and moment generating function guarantee uniqueness of CDF. So I thought we could make function, which is because it's defined by uniqueness. I don't know like how, if we go more injective and bijective, function could be also, we can use it. So moment generating function m prime 0 is become expectation of x, and m double prime 0 become expectation x squares expectation. Thank you.